Okay, so hello everyone, and welcome back to the Efficiency for Access Design Challenge webinar series. You might be able to see this chat here. Let me just move that. So we're excited to have you all here today, whether live or whether you're watching this recording. My name is Sean. I'm on the Efficiency for Access Design Challenge team. You might recognize me from a bunch of the other webinars. And just like Ben, today I'll be hosting. So I'm joined by my colleague Jackie, who will be supporting me, particularly in the chat. So if you have any questions or for us, just reach out to her in the chat. As usual, a bit of housekeeping before we begin. I'm recording this webinar and its transcript, which will be available online. So if you do not wish to be recorded, please turn off your video and or mute yourself. We'll share the recording and the slides following the event. Today we'll be hearing from 3 speakers. So while they're speaking, please mute yourself to avoid any distractions. However, we encourage you to turn on both your mic and video for our Q&A portion of the event. If you have questions during the Q&A period, please use the hand raising function. I think you can find that at the bottom of your screen, and we'll call upon you. Additionally, the chat will be open to questions and comments from our audience throughout the event, and they can be sent in anonymously to Jackie or to everyone. I encourage our speakers to participate there in there as well. If you have any additional resources or just want to engage with the students, please feel free. Following the event, to the students, please feel free to engage and discuss with your fellow participants in the related CrowdSolve post. We might be posting some additional resources there. You can ask us any questions. It's great to get a discussion started. And remember, this year's webinars are organized around the different elements of the assessment criteria. So everything covered today, you'll have to address in your design process. So I encourage you all to ask questions of our panelists while you have their attention. They're a wonderful resource to have here. Today's session is our second in our series on innovation. Specifically, our question highlighted here found in the challenge brief. It's about considering cost in your design, how to evaluate the cost of your design, particularly important for any of you considering applying for a prototyping fund or already done so, and the methods by which you can reduce production costs. And the question from our challenge brief is found here. We'll be hosting a separate section on the affordability and accessibility of appliances. So this session is really focused on production costs rather than the final price for the consumer. And that is in our separate section of the assessment criteria. So here, the webinar's agenda is here. We only have about an hour for today's session, and we'll be hearing from 3 speakers, followed by a Q&A and a few things to close up shop. So without further ado, let me introduce you to our speakers. First up, we have Robin Day. Robin has nearly 45 years of experience of innovative design, technical development, cost-effective manufacturing in aerospace, competitive motorcycle, automobile design, TV sports broadcast, and most recently in the energy-saving LED lighting industry. He is recognized as one of the most reputable designers of highly efficient LED lighting systems in the world, and is specialized in the energy savings aspects of this technology for the last 12 years. Most recently, his work has taken him towards renewable energy storage systems, using solar and wind generation to provide electrical energy for storage batteries. He's currently the founder and technical director of eBettery Limited. Next, we'll be hearing from Douglas K. Bluma. Douglas has over 7 years experience working in the renewable energy industry, majorly focused on solar energy. He is an internationally trained renewable energy engineer with a bachelor's degree in civil and environmental engineering, a postgraduate diploma in business administration, with further business training at Kellogg School of Management as an exchange fellow. Douglas is currently the managing director at Innovex that is transforming the distribution of off-grid energy systems and equipment using IoT digital tools. Finally, we'll be hearing from Nidhi Pant. Nidhi is the co-founder of S4S Technologies, a near farm gate food processing platform that converts farm losses into value-added products for the food and beverage industry by training landless women farmers to become micro-entrepreneurs. Nidhi has been featured in Forbes 30 Under 30 Asia and was a Unilever Young Entrepreneur 2019 awardee, among several other awards. I usually take up a lot of time in our introduction, so I don't want to do that today. I'll pass it straight on to Robin, if you're happy to go ahead. I understand you're not using any slides today, Robin, so I'll just stop sharing my screen so we can all see your face. Okay.
It's good morning, everybody, and I guess good afternoon and good evening in some cases. People will be dotted around all over the world. I'm looking at a great long list of names here. Thank you very much for attending at this morning, and hopefully not just in this particular forum space, but to follow on afterwards. I guess via Jackie or however the communications, the post-meeting communication systems work, that we can communicate with you separately. Right, just to kind of get going, really. I've not prepared any sort of formal presentation because I wasn't aware of how diverse the audience may be. But I just decided that what I would do is just provide some functional pointers from my experience of design and development of products into the marketplace, into various marketplaces, and hopefully to be able to share my experience there, and to be able to advise necessarily post this meeting. So please feel free to engage with please via Jackie or Jacqueline, beg your pardon, and we'll take it on from there. Okay. Cost, the final cost of any product that you design for manufacture is essential to understand, first of all, the marketplace that you're going into. It's a primary part of the business model, ultimately, of understanding where you're going to go. For instance, if you're imagining that your design is going to go into high volume space, high volume manufacture, then a lot of your early calculations have to be focused on minimizing costs at all levels, and there's a number of areas that you need to focus in on there. But first of all is to understand the initial marketplace you're going into. If you're on the other hand, if you're going to go into a smaller niche space, it's also essential to understand the pricing of your ultimately of your product, where your pricing focus is going to be within a range. Sometimes it's worthwhile because then there's a lot of stuff that can be looked at post design, but the pricing during the design process is absolutely essential at the front end to understand processes, transportation costs. There are a number of areas that you really do need to kind of like focus in on anything like that. Now, I was going to take for a model the LED lighting space that we occupied, and I developed a highly efficient light fixtures for a number of years ago. In that particular case, what we looked at was a space where the extremes of energy saving provide a payback later on, because you're saving energy as you're using it. The payback is later on, because factored over a number of years, the cost of running, say for instance, one light fixture or 200 light fixtures or however, this all stacks up and it becomes quite an important model further on down the line. So in this particular case, what I did at the front end of the situation, bear in mind that my principal marketplace for the products that we were producing were the European Union and the United Kingdom, where there were a lot of opportunities for innovation into lighting because there was grants available, etc., for R&D work. That's another element as well we'll go into later on. But primarily, my focus was, first of all, to create an extreme energy saving device. So we looked at what we were able to do with what was available currently in the marketplace as the best of the rest, and understood what the competition as such was, before we began to challenge ourselves with how to raise the level of performance into another plane altogether. So in the creation of the LED light, we looked at it from a number of points. Bear in mind that there is a minimum of components. I say minimum of components. We're talking basically 5 or 6 vital items. One of the first one is the material that was selected, which was the transmission of light through glass in this particular case. And the transmission of light through a particular type of glass, which was fragmented on the front surface by a series of micro lenses. So it gave a diffuse surface at the front end. So you weren't able then to see the pinpoints of the LED inside, but the light transmission through the glass is the highest level. So that's one area. We then looked at materials for treating the inside of the particular light fixture. Now, the light fixture that we selected to offer the best opportunity for energy saving in big spaces, retail, hospitals, schools, big office complexes, and what have you, is effectively the replacement for the fluorescent tube fixtures, which are very, very common, into suspended ceilings or suspended lights using fluorescent tubes. So that was the space that we went into, and the typical light fixture sizes of those types of fixtures is 600 by 600 or 2 feet by 2 feet. It's the American conversion. 1200 by 600, which is 4 feet by 2 feet, and 1200 by 300, which is 4 feet by 1 foot. It's an American conversion. What we found in the marketplace was that basically the way that the LED our opponents had developed their LED was to actually drive the LEDs quite hard, which gave them quite a short period of life, but also consumed a lot more energy than was required. We reversed that. We put a lot more LEDs into the space and ran them at a very, very much lower level, and therefore consumed a lot less energy inside. Inside the light fixture, the reflective surfaces were also worked on, so that light that's bouncing around inside this particular light fixture is all aimed at going outwards. That way you're transmitting the light outwards at an extreme level. So ultimately, our competitors at the time were working out at around about 124 lumens a watt. Now, that's a simple calculation in lighting. It's the number of lumens that's being generated by the light fixture, or the light as an output, versus the amount of energy wattage that's consumed in the development of the light. We were hitting 170, 175 in our designs, which straight away put us then into a niche segment. So this is one of the models where the niche segment became immediately apparent to us and therefore we could then begin to target our cost process it into the niche numbers rather than in the high volume numbers, which were the sub level, if you like, in what is supposed to be an area of energy saving. This niche slot there gave us a very, very big advantage in the marketplace, which has currently been now run out in schools across the UK and Europe, hospitals. Quality of light was another essential element, but that way we also developed over a period of time. Then we were able to reduce the cost slightly because the volume that we were producing went higher. But the key to it all ultimately is looking at what you're trying to achieve in the marketplace. What's the area of focus, and what innovation can you bring to raise your technology into the space and become competitive in that space. I'm then open now to questions. Obviously that's later on in the process, but hopefully my outline of the development and the factoring in the cost as a key analysis point all the way through, I hope that's become quite clear. If not, then please let's pick up on it at a later point. I'll hand back to Sean or Sean and go to the next speaker, I guess. Thank you.
Thanks, Robin. That's great to hear, like the full process of a design. I think that's really helpful for the students when they're working through their own, to start considering it at each point. And yes, if you have any questions, please bring them up with Robin in the Q&A portion. We'll have time for that. I think Robin kept it exactly the time, which is perfect. Can everyone see the slides again? Yeah. Okay. So thank you, Robin. Next up, we have Douglas. So Douglas, would you like to take it away? I think you're sharing slides, so just tell me when you'd like me to change them, and I'll go ahead with that.
Oh, thank you, Sean. Yes, good morning, good afternoon, everyone. I'm Douglas. I lead the team at Innovex, and happy to share our experience on how we think about product costs. Next slide, please. So a bit about Innovex. Innovex is facilitating the transition of solar energy from being a product to a service. It's well known that Africa, sub-Saharan Africa, still holds 99% of the world's population without access to electricity. And solar is a huge solution for this today, but it's not reaching these Africans fast enough. And Innovex, we are here to help solar companies use digital tools so that they can scale in a sustainable way. And next slide, please. So what we essentially do, we build what you would call smart meters. So this is a product we call Remote. It consists of a smart meter and a web portal that is hosted in the cloud. And all this is actually made in-house by us. And how we think about product costs, or if you had to think about the cost that would go into developing a product, I would say that the four main areas that you need to look into, of course, one is the cost of the goods. So cost of the goods is how much are you actually going to spend to buy the materials that will help you make this product. Still, you need to think about the distribution costs. Majorly at design stage, you will need to think about how your product is going to be distributed. If you have a really huge product, big in size, that is very hard to package, it will become very expensive to distribute this product. If you're designing your product, for a market where you need to ship it by air, it's very important to think about how it will get your customers after it has been shipped. Three is sales and advertising costs. This is also something you need to think about still at design stage. And lastly, I would talk about the running costs. Interestingly, running costs are probably one of the most important that you need to consider at design stage. You've had terms such as lifetime costs of a product. These are terms they're using to compare electric cars, to the fuel cars. How much will you spend, owning and maintaining an electric car over 10 years? So it's not just the cost of making this car today, but what is going to be the cost of maintaining it. I mean, for the normal combustion engine cars, you hear of costs of changing engine oil, changing the brakes. So you need to think about all these costs, and they're very important before you put a product on the market, or even before you start prototyping. You consider what the running costs are going to look like. So in my presentation, I might focus a lot on hardware, but there's also the software products. I believe the context is mostly students trying to develop hardware solutions. Then in designing a product, so design actually determines 50% of the cost of the product. So it's very important that you put a lot of time into designing a product. You may well know that it takes years, to bring certain products from, idea to the market. And the medical industry, being the winner on this, it can take up to 15 years to bring a product from, idea to the market. For energy, it's relatively easy because not a lot is at stake as compared to the medical industry. So you probably have a year, 2 years from ideating, prototyping to actually putting the product to the market. So design determines 50% of what this cost could be. And if you compare that to quality, interestingly, quality just has an addition of about 5%. So when you look at the design process, you are going to be identifying a problem. You try to come up with an idea to solve a problem. So it's at refining the solution that my presentation is going to focus. And next slide, please. And in refining your solution, so what you need to think about costs. So this is cost cutting at product design. So one, you need to think about design for manufacturing. Design for manufacturing simply means at design stage, you need to consider how your contractor or how your manufacturer is actually going to manufacture this product. Why this is important is if you look at a product such as plastic, if your plastic is very complicated and hard to manufacture, it makes it more expensive for you to put on the market. So at design stage, you need to think about how the manufacturer is going to actually manufacture this product, and this cuts across all fields of engineering. It's important to think about how this is going to be put in the real form. Right materials, this is also important. You need to think about, the right finishing of a product. What will it look like? What are the aesthetics? And how can you best, minimize waste? So this is a process called lean manufacturing, where you try to lose as little waste as possible. Next slide, please. So then in prototyping, it's commonplace that usually when you think about an idea, many of us rush to prototype. And prototyping, you want to prototype a physical product. So the best way of doing this is trying to come up with what you call an MVP. So this is the best way possible you can test. You can test your idea without investing any money into a physical product or a physical prototype. So you need to minimize prototyping as much as possible. For physical products, it's good these days. We have technologies such as 3D printing, where you can prototype and iterate your designs, but it was much harder those days. So you need to minimize prototyping as much as possible. Only prototype after you have answered a number of questions about your hypothesis. And the good thing is we have what we call computer-aided design. So this is CAD, and there's some images that you see on my presentation. So some of these are CAD designs. So even before you have your prototype, you need to use some of these CAD softwares And some of them actually allow you to test your product, to stress test the product and see how it to simulate and see how it performs in a computer environment before you prototype a physical product. And if the image on the extreme right of my presentation was our very first prototype of our product, and you can see how it moved from a prototype now to the final product that you see below, the computer-aided design image. Next slide, please. So choice of components. So this is important because at prototyping, before you have a commercial product, you need to invest as little money as possible. So you need to use as many off-the-shelf components as possible. So when we're designing our smart meters, the image at the bottom was actually our very first product. So this used an off-the-shelf casing. Because we knew, manufacturing plastic is quite expensive, we had to use something off the shelf. And we actually still use some of off-the-shelf components these days in our products. As you can see, the image on top, most of these are actually off the shelf. So this is a water flow meter. We don't make the water flow meter. That one we source from an existing supplier. So you need to look at, the options you have. Is someone, can I use someone else's designs? Can I use someone else's products? And I don't have to make a physical product. I did talk about an MVP. That's your minimum viable product, so that you can test your hypothesis and get a few questions answered about those assumptions before you move to prototyping. Next slide, please. So lastly is on manufacturing. It's important that you use the right manufacturer. And before you manufacture, you need to ask these manufacturers for some samples. I know samples could be expensive because you're ordering probably a few volumes, 5, 10 pieces. But this saves you a lot in the long run. If you ended up with a wrong manufacturer, you would have a very poor quality product. And this is common today with markets that don't value quality. So you need to ensure that in sourcing your manufacturer, you at least ask for some samples, and that is the best way of evaluating the quality of your manufacturer. And of course, it's important to come up with a very good bill of materials. So after designing your product, you need to list down all the items that constitute this product, and that is what you send to your manufacturer to manufacture your product. So it's important that the bill of material is right. You don't have anything you've left out. And importantly, if you have more than one category of products you're making, try to use similar components along all the products that you make. For example, at Innovex, the smart meters, we have different varied types of smart meters, but all of them use similar components so that we don't have a very huge bill of materials or a unique bill of materials for each of our product lines. And finally, next slide. So for hardware products, you probably, the thinking usually is you should invest as little as possible upfront in design, which is different from software. With software, interestingly, the more you invest upfront, the less the running costs you'll have of the software. Running costs in running the product online, if it's hosted in the cloud, or even the cost of having to fix bugs and errors that could have been made on product design. I think with that, come to the end of my presentation. Thank you.
Thank you, Douglas. That was great. It's good to hear everything broken down so clearly. Everyone, while you might be focusing on the design stage of all this, it's important to consider all facets of cost and how to cut in all areas. So thank you, Douglas. If you have any questions for Douglas, again, please feel free to put them in the chat or bring them up in the Q&A session. Okay, finally, we'll be hearing from Nidhi. Nidhi, are you ready to take it away? I don't think Nidhi is also using a slide either, so I'll stop sharing my screen.
Thanks, Sean, and hello, everyone. I wanted to just give you a brief background on how we went about, my organization, which is Science for Society, went about dealing with costs. First thing and foremost that we do at an idea stage or a prototype stage is to benchmark. So collect as much as data you have of the other technologies available or other costs of manufacturing available either on internet or through any other sources that you have, so that you know what is the industry average and what would be what is the lowest and the highest range that you are dealing with. So for us, we manufacture solar powered food processing equipments for the farmers. As we started deploying our products on field with the farmers, we realized that a very heavy intensive process, a product will not work for, or a very sturdy, we require a sturdy equipment, but we don't want to over engineer it. So because it is not something that that matters to our end customer, for them affordability is equally important. And that's when, after benchmarking it with other dryers, we tried to calibrate both the capex costs as well as the opex costs. So as much as your capex is important, which is your first time cost that is required to build an equipment or any product, it's also important to benchmark what would be your operating cost. So to operate that equipment every day with the least amount, with the highest efficiency and the least amount of energy, what would that cost per kg be? And then try to optimize that. A lot of times what we've seen is that though we are able to optimize on capex, but it ends up increasing your opex. So at the end of the day, your net costs that you're incurring will remain the same, and it is not something that you are able to control. That was the first part, that have as much as benchmarking possible for both capex per kg, whatever your unit is, capex, as well as operating costs, so that you know what your trade-off is. Second is also important to know that all these needs to be customer centric. That what is the life cycle that the customer is looking at. We know that if we make the equipment for 15 years, every 8 to 10 years, the technology upgrades, there are better innovations coming in, the product would become, the generation of the product would keep on being futile, and it would be good to design and be very clear at the start itself what your life cycle cost would be. So whether it is from the perspective of environment, whether it is from the perspective of end user, it is good to understand in years that for how many years you need to make a product, because that will determine your raw material costing. So as much as your innovation so innovation is a process innovation, I'm assuming that you are doing, and also has a layer of design innovation if that is. It would be good to know the life cycle cost and try to see what is the midway that you arrive by optimizing your capex, opex, and also life cycle that you require. And all of that will then determine what your raw material costing should be. So we call it COGS of COGS. So COGS is your cost of good that you're producing, and the cost of that. So if I today produce a food processing equipment or any equipment that is made using aluminum or steel or any raw material, which in itself has a global implication if the price keeps on varying. So during COVID, the prices of all the raw materials started becoming really high. So it is important to be mindful whether what your raw COGS of COGS is, so that so you know that if anything changes, any variable changes, what is going to be its impact on your current cost. Second, and the most important thing in your costing is sometimes also understanding that how can you actually break it into pieces and not have like only one thing for serving the entire purpose. So just giving you an example. Say today I want to remove water from my produce. I can do it with one single equipment doing all the work, or I can do it in two different equipments, which is primary and secondary, that would help you divide your cost. So a lot of times if you see it's an engineering problem and a design problem also, that you are trying to build too many layers, and the same equipment is trying to solve for everything. Though it's a great thing that you are trying to fit everything in one, we are trying to be more adaptive, it's going up in the generations, but at the same time, the challenge also is that always increases costs, because then the cost is not of the process or the equipment to deliver the outcome. It becomes a function of also the usability that you are trying to create for the end user, which could also be one of your innovations, but the base, the base, which is the outcome, is what you want to test at a prototyping stage. So try to keep it as simple as possible. Try to not have too many things that you have to engineer for or design for, that could just, or you want, like you're having a design innovation where you want the legs to be in a different way, that would always increase your cost. And the third and the most important part of it is that be open on using different type of materials. So or don't look at innovation or reducing costs just through engineering or through prototyping, but also through material changes. What effect would it have on the whole process? So yeah, these are some of our understandings. First is to know the raw material price changes, then to also know the life cycle cost and and benchmark it with capex and opex per kg. See if the equipment is not too over-engineered. You don't want it to be frugal, but at the same time, you don't want it to be also too complex for it to, that you are wasting all your money just in, like, better designing of everything. Yes, it is important for you to get the right design, but at different stages, it should be your priority, because here maybe you're just testing for something else. But if your innovation is a design innovation, then you should definitely focus on getting the design right. And the last and the most important would be to be open to different sort of materials that can actually help you bring down the costs. So there could be a process innovation, a product innovation, design innovation, and also just what you use as materials, that innovation that will help you reduce your OPEX, operating costs. So these are some of the experiences that I would want to share from my organization that we track, and can take any questions if you all have.
Thank you very much, Nidhi. It's great to hear, and it's a good. I don't think we heard a lot about balancing the reduction in cost and improving innovation and trying to balance the two. So it's great to hear that as well. And I think people will have questions for you as well. So let me just pass on to the Q&A portion. Let me just share my screen briefly. Does anybody have any questions early on? I see we have one in the chat. We can keep going. Anybody feel free to turn on your mics and videos and get engaged here. Thank yous to all the speakers. Great presentations. Looking forward to the questions. I think the first one goes to Douglas, asking what your motivation regarding Africa is. And I guess that's asking why you're focusing your work in Africa.
I think the quick answer would be, well, Africa is home. And definitely we are out of admiration of how far other continents have gone. It's the sole reason why we first of all focus on Africa, and it's where the problem that Innovex addresses is occurring at the moment. So it's home, and we, as a team of highly passionate Africans, we are challenged by how far or how much work needs to be done. Yeah.
Thank you, Douglas. Great to highlight your team as well. I think this is to Nidhi. We have another question in our chat from Stephen. In your presentation, you use the word CAPEX. Could you please elaborate on this? What the term means?
Yes, I'm sorry for using, I was not being very mindful. Capital cost, that is that to make an equipment, what is the first time cost that you would incur? That would be your capital cost. So if say you have a water purifier, if it is for say $100, your one-time cost would be $100. And then if you want to clean it, you want to operate it every time, there's some cost associated. So that is your operating cost. That could be the cost of the electricity that it is plugged in for the water to be purified. So that would be your operating cost.
And that was OPEX, right, Nidhi? Yeah.
Yes.
Okay. Okay. Okay, great. Another question from Venan. The greatest challenge with innovation and design is funding. How did you go around that? Robin, would you like to take that one?
Yeah, funding is always a challenge. Okay, I mean, kind of starting from the ground up. We've recently gone through an evolution inside the company, away from the LED lighting situation, in towards more where Douglas is operational at the moment, and the use of solar energy. Or Nidhi is also operational in that space, but we're focusing on energy storage. And our first challenge was going to be funding, not just funding for R&D, but funding then for manufacturing base, etc., etc., etc. So the way we looked at developing the project in terms of the funding process was to create a business model based on what we were developing, what was our vision, what was the technology innovations we were bringing forward, where it would specifically suit the marketplace, and then went out to secure venture capital or grants, because there are a number of grant options available for in certain countries. I'm afraid it's not necessarily fully the space, unfortunately, but in the UK we have a very progressive system here, which is about encouraging innovation, because innovation then is creative and brings and adds to the export process. So the government is very, very active on grants. So very simply, create a business model which shows why you're different and why your product is special into the space. It's an ideal thing, a very typical PowerPoint presentations. You've got to do a certain amount of work on your own, which is developing the cost basis, where it's to be manufactured, all of the parts of typically being involved in the creation of a business and running the business. And that then gets factored back into the cost of your product to go. And then you work out the potential sales of your product into the marketplace. But it is key to get the business model correct in the first place. Otherwise, it's to look around and see if you can find grants. Over.
Thanks, Robin. And I think that's important for everyone because we run these pitching sessions at the end of the design challenge, and they function very much like the real world. So it's important to get your business model down for that as well. Robin, there's another one in here for you from Wally asking, you talked about creating business models, which software is required for that, and to help in that process.
Well, okay, start with your designs. So you've got what we found very, very useful is to use 3D computer aided designs, because then you're actually able to create very much as Douglas has demonstrated his 3D models for the casings of the housings that he's using, etc. But that then allows you to create all to be able to look at all of your costs in the design process. But then also you're able to take those images and put those into, I would suggest JPEGs. It's the very easiest way of doing it as far as my understanding is. But then again, I'm not a computer guru when it comes to all of the toys you can play. But then you, by using those features, you can then make your presentation on PowerPoint. And then PowerPoint, your business model always has to be done on an Excel spreadsheet anyway. So your business model develops on your Excel spreadsheet, but then you've got all of your R&D costs, your development costs, all of the costs that have gone into what you're looking to achieve. And then potentially you're able to then demonstrate the value of your innovation into the marketplace by having worked out all the numbers properly. So very, very simple. 3D CAD is ideal. I use SolidWorks. It's a superfitted kit, and you can rent it on a daily, hourly basis. Other than that, PowerPoint for your presentations and Excel for your financial presentations, because that allows people to crunch the numbers afterwards. I hope that's answered the question.
Yeah, thank you, Robin. And if anyone has any follow-up to that, please feel free to ask in the chat. But very clear. Then I think the next question is for Douglas. Are there links where we can get access to startup funding, whether grants, as Douglas mentioned, or try using off-the-shelf pieces, but these are still expensive to land in some parts of Southern Africa?
Thank you for that question. It's still related to funding, and surprisingly, your level of funding actually determines what route of product development you take. If you have the funding that you actually need, probably it's a better landing. But in most cases, especially here in Africa, it's usually not the case a number of times. So, for example, why we actually initially had a product that was packaged in an off-the-shelf plastic is because, you know, our level of funding didn't allow us to make a custom plastic. The good thing about, you know, I think we're lucky because ours wasn't a consumer product. So how it looked wasn't a key criteria for someone buying or not. It was more the function, the fact that it could meter, and the installation, it's installed somewhere that people don't have access. So the level of funding is really important, but not the most important, I must say, because we pulled it off without funding initially. Well, our initial funding actually was an upfront payment from a customer. So we pitched the idea, like Robin said. I mean, we met the customer, we pitched what we wanted to develop for him, they made the payment. Then the prototype you saw in my presentation, that first prototype, we built 3 of those out of our first payment. And that is what we sold to the customer. Then he paid for more units. So that is how we initially developed Remote. And after gaining traction, by traction, we had installed close to 200 units across Uganda. Then we met Efficiency for Access, a grant. And because we had traction, then Efficiency for Access, it was validation enough that the problem we're solving had a market. So that's why Efficiency for Access picked it up. Efficiency for Access is the program where you're participating now. So they picked it up and they funded our continuous research and development. We now have a custom-made plastic. So all the CAD drawings you actually see of the plastic were paid for with funding from Efficiency for Access. Those we couldn't afford in the beginning of developing remote. So start, where you are, it's possible. And in Africa, you need traction to access money. So you need to be very creative. Traction is very important for you to access money. And it also gives you a lot of validation that the problem you're solving actually exists.
Thanks, Douglas. And just to remind everyone, there is, you can apply for prototype funding through the Efficiency for Access Design Challenge. So feel free to get your prototypes kickstarted through there. And I think we have time for one last question from Stephen in the chat. Says, in terms of the products to be innovated, I listened very well, and it's like we need to come up with a product that's more portable to be transported. What if a product is a bit larger in size to fit that goal, to fit the goal of the product, and how can we make sure it's smaller for portability? So maybe we can just pass this one off to Nadi to close us out. If you can help with this one, I know that work more on farm products. Is Nadi still in the room? Maybe she dropped out. Yeah, maybe Nadi had an internet connection problem. So either Robin or Douglas, would you like to take this one?
I could maybe just give a comment and Robin could supplement. I mean, it doesn't need to be a portable product. If the solution calls for, if you're building a water purification system, there's no you can get it so small. If it needs to be big, let it be big. What you need to think about is how it's going to be distributed. How are you going to package it for distribution? I think that's what I can say. Over to you, Robin.
Yeah. I mean that's a fairly good follow-up. Yeah. My own experience of water purification, though, is the water purification does tend to be quite large. If you're going to be dealing with any sort of like volumes of water, so it's the possibility of but then again, I'm only looking at it from a perspective of actually using light to pass through water to kill microorganisms like that. And what you're looking for light-wise there is C's and D's, B's and C's gamma rays to be able to kill those things. They tend to be fairly large. If you're looking at anything else with regards to filtration and possibly the addition of chemical, I guess really then it's probably smaller. But yeah, I think it's a kind of like a tricky one. But I'd be interested to know what you'd like to do with it and where you'd like to go, because I might be able to give you some advice, more of a technical base to be able to assist you to grow that design. Over.
Sure thing. And everyone, please feel free to send us any questions you might have after, if you're watching this recording, or if you think of any after, over email, or to engage in the CrowdSolve post online. So thank you to everyone. Thank you to the speakers for sharing your expertise in those questions. And before we go, I'd just like to ask everyone to complete this short feedback survey. There's a QR code on the screen, so if you want to scan that. Otherwise, the link is at the bottom of the screen and in the chat. So that only takes a minute or so to complete. So please try to complete it now or as soon as possible. This really helps us to improve each session yeah, improve with each iteration. Finally, we have this newsletter sign up. So this is important if you want to keep up with any news relating to the design challenge, any upcoming webinars, some stories that are coming out of the challenge. And yeah, it's just a great piece of copy for everyone to read. Yeah, I think it only comes out every few months, so won't be spamming you. And that, I think, closes up the session for today. So thank you to Robin, Douglas, and Nidhi. It's been great to hear you today. And thank you for coming along. Thank you to all of our participants for coming today. It's been a great session. And have a nice day.
Thanks for setting it up. Bye-bye.
Thank you. And bye.